Alright, so today we are going to start some arithmetic sequences. Tomorrow we'll deal with arithmetic series. Friday we will deal with application problems involving arithmetic sequences and series. So, hate to break it to you, that's fancy word talk for word problems on Friday. Okay? And then remember, I haven't updated the board yet, but you'll have a quiz on the 4th and the 11th. Yep. So we got that going on. So a tall brick building has a decoration as shown. If each row is a foot tall, how many bricks would be in the bottom row if the wall that this design is going on is 15 feet tall? And how many bricks would it take to build the whole wall? Okay. That's an arithmetic sequence and series type of problem. The first one is an arithmetic sequence question. The second one is an arithmetic series question. Very typical problem from this section, from this unit. Okay? We'll be able to solve the first one in about a half hour. Okay? Tomorrow we'll tackle the second one. That's when we're going to deal with sums and series and all that fun stuff. Okay? But so let's jump in here. Okay? Arithmetic, the word arithmetic, when dealing with sequences and series, is a sequence that has a constant difference between consecutive terms. Okay. Another way of saying it is it's a sequence that adds a specific number to get the next term. So if you add 5 for the first term, you got to add 5 the rest of the way through your sequence in order for it to be an arithmetic sequence. If you add 5 and then subtract 2 and then add 6 and then so if you add 6 more, not arithmetic. Okay? The difference is not constant. Okay? This first one, as we go to each term, down a little bit. No, I can't bring it back. I can bring it back. Nice. We're always adding 4 to get the next term. 3 plus 4 gets me 7. 7 plus 4 gets me 11. 11 plus 4 gets me 15. 15 plus 4 gets me 19. 19 plus 4 would give me the next term. 23, 27, 31, 35. What? 4 is 31. Nope, plus 4. Yeah, because it's always got to stay the same. Okay? So that works out. That's an arithmetic sequence because the difference between consecutive terms is always constant. Same thing on this second one. On this second one, it is also arithmetic because the difference is -5. You're adding -5 every time. You might just call it you're subtracting 5 every time, but that's the same as adding a -5. Okay? This number down here and down here, we call that the common difference. We call that number the common difference. So, let's talk about these four. Give me a second to write them down. Adding 10, right? Adding 10. Adding 10. Always adding 10. So is it arithmetic? Yes. That common difference, the symbol for it is just a D. So our difference there is 10. Second one, arithmetic, not arithmetic. Why not, CJ? Because it goes what? Plus 3, then plus 5, and then plus 7. Third one, arithmetic, not arithmetic. Nick, why not? Yes, it is.
Yes, by 2.
I'm confused. You're adding -2 every time? So does that make it arithmetic? Okay. So it's not arithmetic because we got to look. So here we added -9. Here we added positive 18. Here we subtracted 36. So therefore, no. D, what about D? Why, Hunter?
You're adding a negative.
Love it. All right. All arithmetic sequences have this as its rule. Okay? Last night in your homework, you were asked to find the rule, and you just had to willy-nilly try and come up with it. If it was all the arithmetic ones, could have followed this pattern. Okay? And the pattern is that any term in the sequence is equal to the very first term plus the total number of terms n minus 1 times the common difference. Now, this first term, that's a must-have. You gotta have that in order to find the rule. You gotta know where to start in order to find the rule. This common difference, that's also a must-have. Okay. You've seen this before. You saw this last year in Algebra 2. Okay. Hopefully I'm just firing off some more, some old and outdated synapses. Okay. So, let's find a rule given the, write a rule for the nth term, and then find the 20th term, it say. All right? So, 1, 3, 5, 7, and so on and so forth is my sequence. What is my first term? What is my common difference? Adding 2, so my common difference would be positive 2. Okay. Based off of that, we can now go to our formula. A sub n, or our rule I should say, is equal to my first term plus the total number of terms minus 1 times my common difference of 2. Okay. So when I'm writing my rule, I could write that as a sub n equals 1 plus 2 times n minus 1. That's the ugly version of the rule. Or I could write it as a sub n equals 2n minus 1. That's the pretty version of the same rule. How did I go from the ugly stepsister to the princess? How did I go from this line to that line? Distributed the 2 and combined like terms, right? Okay, yep, that's exactly what you do. Okay, sometimes it's easier to use one than the other, okay? But you got them both. All right, now we've got to find the 20th term. So using my rule, a sub 20, I'm going to substitute 20 in for n. 2 times 20 then is 40. 40 minus 1 is 39. So I get my 20th term is 39. Or I could go 20 minus 1 is 19. 19 times 2 is 38. 38 plus 1 is 39. Questions, comments, concerns, clarifications? You try example B. I get 6 minus 4 times the quantity n minus 1 is my rule, the ugly one. Negative 4n plus 10 is the pretty one of the same rule. And I get the 20th term to be negative 70. Clarifications, comments, concerns, questions? Okay. That's one style of problem. We'll give you the sequence. You'll see that a lot this entire unit, where we'll just give you the sequence and we'll ask you to find the rule, find a specific term within that rule. Okay? Another style of problem that you will see is I'll give you a one term and the common difference. Okay? And so then from that, utilizing the rule, so you know that your sixth term, what this is saying right here, is that the sixth term is negative 16. So if we use the rule, negative 16 would be my sixth term. That's going to equal, I don't know what my first term is. I know that my sixth term is what we're talking about, minus 1. And I know my common difference D is 9. So I can use that math to find my first term. So I'd have negative 16 here equals my first term plus 45. 6 minus 1 is 5. 5 times 9 is 45. So that gives me negative 61 as my first term. Then it asked me to find the 18th term. Nine times 18 is 162. 162 minus 70 is 92. Okay. Try letter D. I get my first term is 74. If my first term is 74, then my rule is going to be 74 minus 7 times the quantity n minus 1, or negative 7n minus 81, or excuse me, plus 81. And then my 18th term, negative 7 times 18 is negative 126, plus 81 is negative 45. Yes?
On the homework, do we have to put both of those?
One of them.
Just one.
Mm-hmm. Okay. Writing a rule given two terms is a third style of problem that you will have in this section. Unfortunately, it's the most involved one because you have to write a systems of equations using the rule. So you got to use the rule for each of the two terms that you have. So if we take this first one and I write a rule, well, that would be 21 is my a sub nth term. I don't know what my first term is. I don't know, excuse me, I do know that 21 is my 8th term, and I don't know what my common difference D is. So I can fill in that for that particular term. For this particular term, my second term, I would say 97 is equal to a sub 1 plus 27 minus 1 times D. Okay. Now I can make the, I know what 8 minus 1 is. I know what 27 minus 1 is. So I can write this as 21 equals a sub 1 plus 7D. And I can write this one as 97 equals a sub 1 plus 26D. Now I've got two equations, each with two variables. I can solve that. We've got substitution, we've got elimination, we've got graphing, we've got matrices, we got all that stuff. Your go-to jam, probably on this one though, is going to be elimination. Because you're going to multiply this entire equation right here, or one of them, I don't care which one you multiply, but you're going to multiply one of them by negative 1. Because then you get negative 21 equals negative a sub 1 plus 7D, and you keep the other one the same, and what happens? Oops, excuse me, tap the brakes. This right here should be negative. What do you got? What happens? With what? With just D, right? Yeah, because the a sub 1s cancel each other out. Negative 21 plus 97. Negative 7 plus 26. $19. 76 divided by 19. 4. Okay, so we got D, we got our common difference. Now what? Plug it in and find your a sub 1, right? Your first term? Yeah. Okay. So this is going to be 21 equals a sub 1 plus 7 times 4. 7 times 4, 28. So this is 21 equals a sub 1 plus 28. What do you get? So my first term is negative 7 in this sequence. My common difference is 4. Do we have enough information now to write ourselves an equation or a rule, if you will? Yeah? What is it? Talk to me. A sub n equals times the quantity n minus 1. Yep. Or if we wanted to, we could write that as a sub n equals 4n minus 11. Yeah? Try that one. So I got that. I got my common difference is 9, and I got my first term is 4. So then my rule would be 4 plus 9 times the quantity n minus 1, or 9n minus 5. Yes? Then it also asked us to find the 25th term in that sequence. So that's going to be 9 times 25 minus 5. 9 times 25 is 225. Minus 5 is 220. Yes. Reading directions is crucial. Tells you what you need to find, especially in this stuff, because we could ask you for the next 4 terms. I could ask you for just the next term. I could ask you for a term way on down the road. I could ask you for the rule. I could ask you for multiple things in there. Okay? Reading directions is key. Yep. On part of those, I don't remember which particular numbers they are, but the directions in the textbook say that you are also supposed to graph the sequences and on a coordinate system. They're linear. Okay? I know that already. Okay? It's always going up by the same amount. You should also know that it's linear, and the slope of that line is your common difference d. Okay? So no need to graph those, just straight up. Find the rules, find specific terms, tell me if it's arithmetic or not, why or why not.